A coordinate system in meters is constructed on the surface of a pool table, and three objects are placed on the table as follows. A 2.0 kilogram object at the origin of the system, a 3.0 kilogram object at 0.02.0, and a 4.0 kilogram object at 4.00. Find the resultant gravitational force exerted by the other two objects on the object at the origin. So I just labeled the origin A, the point 0.2.0 B, and the point 4.00 C. And the masses correspond to those. So mass A, 2.0, mass B, 3.0, mass C, 4.0, as given in the question. Now, the first thing we should do is divide, because we have two different objects at two different places, one on the y-axis, one on the x-axis, we should divide the gravitational forces accordingly, because we're going to get a gravitational force, and here's a little peek at what's going on here. We're getting a gravitational force going up and going to the right, which is going to give us a net force up and to the right. Now that's due to the fact that the masses at point B and point C are larger than the mass at point A, so there's going to be a net force in that general direction, as you can see. So let's find the gravitational force between mass A and mass B first. 6.673, which is times 10 to the negative 11th, is the gravitational constant G, times 2.0 kilograms, the weight mass at point A, times 3.0 kilograms, the mass at point B, divided by r squared, and as you can see, the distance is 2.0, and there you go. You get 1.00, some very long decimal. And now for the second one, we're going to do the gravitational force, the second gravitational force, and that's the gravitational force between point C and point A. So here is our setup. We get 6.673 times 10 to the negative 11th. Same story here. We're just multiplying instead with a mass, the mass at point C, and the distance is larger with 4.0 meters instead of 2. And then we get a different answer. It's a little smaller. So now we make ourselves a little vector triangle. Force G1 is moving up in that general direction, 1.0095 times 10 to the negative 10th newtons. Force G2 is moving to the right, 3.3365 times 10 to the negative 11th newtons. So we want to find this force, the net force. So the way we do that, we use the Pythagorean theorem. Force G3 is equal to force G1 squared plus force G2 squared. And then we get, if we just plug those in, we get approximately 1.1 times 10 to the negative 10th newtons. But now we need to also find the angle at which it's going. So we know just from our instincts, if we think about it, because it's going, these two objects are larger, so they're going to go, this object at point A is going to go in the general directions of these two. So going up and going to the right, it's going to create a net effect of going this way. You can think of it as going north, west, northwest, or northeast, northeast, northeast. Now, in order to find the angle, we can just use our little formula, tangent theta. If we just call this angle theta, tangent theta is equal to one side on the opposite over adjacent, 1.0095 times, forgot zero there, whoops, 1.0095 times 10 to the negative 10 newtons divided by 3.3365 times 10 to the negative 11 newtons. Use trigonometry, we get approximately 72 degrees. Because we know it's going this way, it's going to be above the x-axis, so we can conclude that the net force is 1.1 times 10 to the negative 10th newtons at a positive 72 degrees.